Alright guys, nice to see you again and welcome to another Chemistry Homework Lab video, and here we're going to be exploring electrolysis. Now this is just a quick little video to show you a simple experiment you can do to look at a decomposition reaction. You may have looked at the decomposition reactions to do with heating a carbonate or with elephant's toothpaste, or you may have looked at the idea to do with light, okay, right, making that fish sound, right? Light. So let's have a look here. We can see that with decomposition, just a reminder, a bit of active revision, that is breaking a larger compound down into simpler compounds or elements. And so here is a generalized diagram to show you that if we have a compound A, we can break that compound A up into B and C, which are simpler compounds. But of course, we're using some energy here. Remember, to break something apart, you need to apply energy. So if I had a stick and I was to try and break that stick, I have to apply energy. Well, the same is for chemical compounds. And so to break a chemical bond, we need to add energy. Now that energy can come from heat, and we've looked at a reaction to do with that, heating copper carbonate with a Bunsen burner, that'll do that. We've used light with some silver halides. We can add light to those and they will break down to give us solid silver. In this case here, we're going to be using electricity to break down some water into the elements hydrogen gas and oxygen gas. We could also use catalysts, and that's what we did with that's what we did with the elephant's toothpaste. But the catalysts don't actually break the bond, it just makes the reaction go faster. So what's actually breaking the bond is light for hydrogen peroxide, but with the catalysts made the reaction go faster. Okay, so let's look at electrolysis here. Now here's a simple setup, and there's multiple types of setups. I'm going to show you two other types of setups here. This one here is a very simple setup, which we'll do another video on, where we can actually measure the amounts of gas. But what we're doing here is we've got some water. We've added some salt into that water to increase its conductivity, because pure water by itself doesn't conduct electricity. We need to make sure that we have salt in it. So we've got salt water there. And what happens is we can use a battery, and that battery is a 9-volt battery. Okay, and that will then allow the energy to break apart the water. And these things here are called terminals, or electrodes, and that just basically function to allow the electrons to come into contact with the water. And so what's actually happening here is we're breaking the bonds between the hydrogen and the oxygen atoms in the molecule, and we're making H+, so this bond will break and we'll make H+, and then we have OH left over. Okay, and then some more rearrangement occurs to eventually produce our molecules of hydrogen and oxygen gas. And we can see that we've got some hydrogen gas being produced there and some oxygen gas over there. So let's have a look at a very simple way to do that with a 9-volt battery. Is two pencils. You sharpen both ends of the pencils, and you can see here from this picture that if you just put those pencils into some water, in this case it's a Petri dish, then we start producing bubbles on the ends of the pencil. The graphite inside the pencil, which is carbon, is acting as the terminal or the electrode. Okay, we can actually do it a little bit more sophisticated by using a jar. Here I've got a coffee jar, and I've got a 9-volt battery, and I've got my pencil stuck in, and the same thing's happening here. But if you have a look at the video here, you can see the bubbles are being produced at the pencil tips. What do you notice? Well, there's lots of bubbles being produced at twice the rate on one side of the electrode compared to the other electrode. So they're both producing bubbles, but one's producing a lot more compared to the other. And so what I tend to say is, what do you think that gas is at the electrode that's producing lots of electrons? Well, if you have a look, think about the formula of water, H2O, you're going to be producing twice as much hydrogen as you are oxygen. So on that electrode, it's going to be the hydrogen gas. If we have another look at the setup, I've actually put some universal indicator in. Now, universal indicator changes color based upon pH. And you can see here that on the terminals, they're changing different colors. One terminal is becoming a bit more yellow, which is indicator that you've got an acid being produced, and the other terminal is going more purple, which is indicating that you have a base being produced. So this is giving us more evidence of what gases are being produced at the terminals. All right, let's dig into this one here. So we know that this one here is producing a large amount of bubbles, so therefore that's going to be hydrogen, because we know that the formula for water is H2O, so there's double hydrogens for every oxygen. So that's hydrogen gas. But what's happening with this purple here? Now purple indicates for universal indicator that it's a basic solution. So how can this be? Well, remember that around this tip here, okay, it's making hydrogen gas. So if you know that water is H2O, then basically, and this is not a technical equation, but if you're removing the hydrogen, you're leaving some O behind and some hydroxide behind. So what's actually happening is if we have water here like this, okay, then one hydrogen is taken off there, combines with another hydrogen and leaves us with OH. And so we have an excess of OH around this terminal, because we're breaking off a hydrogen here and another hydrogen from another water molecule, adding those two together, and you're getting the hydrogen gas there. So due to the OH minus, we're getting a basic environment. Well, what about over here? Well, over here, this is where we're going to be producing the oxygen gas, and we know if water's like this, and then if we're breaking off a bond here, and we're breaking that bond, we've got some oxygen there. The two oxygens are going to combine to give us an O2 gas, which means we're going to have an excess of H+. If there's an excess of H+, we're going to have an acidic environment around this terminal, and we can see that we've got like a yellow tinge here. So down here is green, so we've got neutral, that's where we started from, but around the actual terminals we can see that there's a color change indicating and solidifying that what type of gas has been produced. So that's sort of how you work that one out. So I hope you learn a little bit about electrolysis there, the decomposition reaction using electricity to break bonds, and we can do it simply just in a Petri dish, or we can do it with a little bit more work and some color indicator and etc. in this. But in the next video, or in another video I'm going to make for you, we're going to go even further in our quantitative analysis of electrolysis, where we use a device that's going to actually measure the volume of hydrogen and oxygen gas, and then we can also do confirmatory tests for hydrogen and oxygen. We've already previously done a confirmatory test for hydrogen, that's the POP test, so we're going to revisit that, but we're going to look at the confirmatory test for oxygen, which is the splint test. Alright, I hope you liked that video, and if you want to check out your chemistry or your biology or your physics or even your geology, come check out the courses on theflipteacher.com. They're going to be opening up in the 1st of December, and there's going to be a coupon code there to get them cheaper than what you normally would, because they're still being built. But however, I try to incorporate lots of videos, lots of practical videos and graphics to make your high school studies make sense, because let's face it, in the normal classroom sometimes the teacher goes too fast, sometimes you don't get everything down, you might be sick, you might be away, or you just need to look at a concept from another alternative viewpoint. And especially with COVID, how we can do a lot of learning at home, we know how important having a structured learning environment is. So there's about 100 videos per course, and of course we go from year 7 to year 10 in each concept area. So if you're doing the chemistry course and you're in year 7 but you want to push your brain cells a little bit further, you can do chemistry from year 8, year 9, year 10. So there's nothing stopping you. Alright, so hopefully you enjoyed that. Come check us out on theflipteacher.com, and I'm going to make some more videos. See you soon.